Combination of functions. Two functions f and g can be combined to form new functions f plus g, f minus g, f times g, and f divided by g in a manner similar to the way we add, subtract, multiply, and divide real numbers. The sum and difference functions are defined by the following. Here is the sum. F plus g of x is equal to f of x plus g of x. F minus g of x is equal to f of x minus g of x. So if I have these two functions, and let's say that I want to go ahead and solve for f plus g of x, we write out the definition to be f of x plus g of x. We know that f of x is the square root of x, and we know that g of x is the square root of 2 minus x. So it becomes the square root of x plus the square root of 2 minus x. Now, the domain of each of these combinations is the intersection of the domain of f and the domain of g. So in other words, both functions must be defined at a point for the combination to be defined. So if we take a look at the first function, square root of x, the domain of that is bracket 0, comma, infinity. If we take a look at the next function, g of x, the square root of 2 minus x, the domain of that is parentheses negative infinity, comma, 2 with a bracket. So if we wanted to find the domain of this combination, meaning that once we find a domain of what we put together, well, the domain is going to be the intersection, meaning that it's going to cover everything from the bracket of 0 all the way to 2. So that would be the intersection. So what I mean by intersection is, let's take a look at the graph. Okay, so if I have the graph, and let's see that here we have 0, and this bracket is going towards positive infinity. And then we have negative infinity going all the way to 2. So here's 2. So here's 2 going all the way to negative infinity. So what you see here is that this intersection between 0 and 2 represents the domain of when you combine those functions. So that is the intersection. Now, it works for the addition, for the subtraction, and for the multiplication. But now when we get to division, we need to be careful with one thing. And that one thing is if the denominator is 0. So if we take a look here, we have f of x, which is equal to x squared, g of x, which is equal to x minus 1. So if we wanted to then find the combination f over g of x is equal to f of x divided by g of x is equal to x squared over x minus 1. So let's take a look at the domain of x squared. So we know that the domain of x squared is all real numbers. And then we know that the domain of x minus 1 is all real numbers. However, when we combine them, we have this denominator, and we need to exclude the value of x minus 1. So this x minus 1 cannot equal 0. So therefore, x cannot equal 1, which we have to exclude in our domain. Next definition. Given two functions f and g, the composite function f composite g, also called the composition of f and g, is defined by the following. F composite g of x is equal to f of g of x, where g of x becomes the input of f. Now, the domain of f composite g is the set of all x in a domain of g, such that the function g of x is in the domain of f. So in other words, f composite g of x is defined whenever both g of x and f of g of x are defined. Figure 11 shows how to picture f composite g in terms of machines. So the f composite g machine is composed of the g machine first and then the f machine. So step 1, you input x into the function g. So x must be in a domain of g, and then the output you get g of x. And now in step 2, you're going to input g of x into the function f to get the output f of g of x. And now g of x must be in a domain of f.